Angie and I were talking at lunch today about our first plenary speaker and how when both of us entered this community N numbers of years ago, one of the first conferences I ever attended, I remember meeting, I'm going to say that kind of in quotations. I sat in the audience and was too shy to talk to them. People like our first speaker, and John Neuberger, and Bill Mahavier, and Lee May, and I'm going to forget a ton of them, but I sat there and I listened to what they said about different ways to engage students. And I thought, wow, that's something. And I was petrified, but I went home and I tried it. And my teaching's never been the same. And so Angie and I discussed the fact that we were both very influenced by this first speaker, and then we arm wrestled to see who could introduce him. It's a good thing it wasn't a foot race, because Angie would have won that, but I got the arm wrestle. So I am extremely excited to be able to introduce Ed Parker to you. Ed Parker graduated from Guilford College with a major in mathematics and minor in philosophy and religion. He earned his PhD from Emory University. He went on to teach at Pan American and then James Madison University, and he's now a professor emeritus and a visiting faculty member at Guilford. He has his vita just goes on, and I'll let you guys look at that. A ton of research publications and books and papers related to teaching. It's amazing. And he's taught most every course out there and is a proponent of more method teaching at all levels. And what do his students say? Well, according to Rate My Professor, yeah, you guys laugh because you know. So Dr. Parker is the best professor I've ever had, hands down. He will challenge you and you will be better for it. Enjoy his class. What a great review. He's awesome. Parker makes his classes an experience, not cut and dry. I'm not sure if that's a good one or a bad one, but there you go. Dr. Parker has received poor ratings by people who don't have the patience to work with him since he doesn't teach through a textbook like most other professors. But you'd learn a lot if you engage during class time. I'd recommend him, especially if you're a future teacher. He's super wise. It's a different experience worth having. I think that's really cool. You'll like these next two. You cannot refer to a book for help. Don't you outlaw that? Say no if you were considering having him as your next teacher. This is the person who wants to look everything up, right? He makes up his mathematics. I couldn't find the theories he used anywhere in the book or online. Several times I went to his office because I was stuck on a problem. He always responded with a question. His questions allowed me to gain further insight into my argument and helped me finish the proof. There's no better way to learn math. So here to tell us more about his style of teaching is Ed Parker, speaking on some reflections on issues in implementing inquiry-based pedagogy in mathematics.
I read somewhere, sometime, about an interview with George Polya, where somebody asked him why he was a mathematician. He said, I wasn't quite good enough for physics and I was a bit too good for philosophy. I finished at Emory in 1977, and my mathematics wasn't quite good enough for an R1, but it was a bit too good for a community college. Elwood's not here, so I'm the only one in the audience that's met my mother, except for Sally. To say that she's optimistic about everything turning out right, if she'd have been on the Titanic, she would have said, oh, it's good, there's plenty of ice for the drinks. And ending up at a regional where my first responsibility was teaching, but there was support for research, is probably the best thing that could have possibly happened to me. Here's my career track, places I've taught. You'll notice that they start and end at the same place. When I was trying to think of some way to get some audience participation today, I thought this would be an appropriate place to sing Will a Circle Be Unbroken, but anybody that's ever sung with me knows that would be a big, big mistake. But here, to the best I can remember, the courses I've taught. I'd be willing to bet I've got to intersect just about everybody in this class, in this room, somewhere on that list. That's the blessing that my mother would have thought of that I would not have ever guessed. There's everything from remedial arithmetic at Pan American University to a graduate seminar in differential equations up there. I've grouped them into 4 sections here. The high school courses, the mathematics for liberal arts, the sort of mainline, that's 5, bad count, Ed. The mainline curriculum for the service curriculum, the teacher training, the teacher education courses, and then the up-level courses that are special to the math major. And in this talk, I want to, in the spirit of the conference, thank you, Jackie, for the outline, I want to address 3 things. The thing that's closest to my heart, because that's what I think makes IBL possible, is finding for whatever place you're teaching an appropriate level of rigor. Proof is at the heart of mathematics. I think it's what separates us from everybody else. And I think it has to be there regardless of what course that you teach. But rigor to third-year graduate students is different than rigor to a 6th grader, and rigor to a college freshman, and rigor to a senior math major. Assessment opportunities. We have to give grades, and the things that the extra opportunities that we have because we hear what our students say are a big, big deal. And then the possible social challenges. I was telling Sally last night, I don't know why I was so agitated about having the opportunity to speak to this crowd. And I think the problem is that everybody's friendly. You're here because of what I do rather than to come heckle, except for personal friends. I know why you're here. So I want to also talk about the possible social challenges associated with those. Now, as far as an appropriate level of rigor, here are the questions I ask myself. To what mathematics will the students I will teach have been exposed? In other words, I want to at least make a reasoned guess at what I'm working with. And then, if I'm right, what foundation, granted that I can get it into language the way I want it, will be accessible to that experience, and from which foundation the students can actually build a course. Now, this conference is about talking to each other. As much as I want this 5 minutes for myself, it's going to be yours. So you've got 5 minutes. Each table, what I'd like you to do is to pick one course from the list that follows, and I want you to address my 2 questions to the extent you can. Here's the list, and what I'd like you to do is to answer the questions that I ask about it. At very least the first one, where I teach this course, to what would the students be involved, and then if you have some time left over after you go around the table and see what you're working with collectively, what foundation is likely to be accessible to that? The clock is on. Harry showed us how to make 1 minute long. I just showed you how to make 5 minutes short. But this is what this conference is all about. You'll get a chance. This is a good way to prime the pump, I think. I hope you had a chance to at least exchange some ideas briefly. But there'll be ample opportunity to follow up in the roundtables tomorrow and on through the conference. In this course list, I've got a few courses bold-faced. Because here's some courses where, as a teacher, I experienced epiphanies. In that first grouping, which of courses I taught at Bayside High School in Virginia Beach, Virginia, Math 3, Math 4, that's the first time I ever got to teach a course that was palette. Benny Jermashausen let me be a part of that even though I was just a second-year teacher. And he told me a piece of advice that has stuck with me. He said, Ed, these are remedial students. If what we were doing worked, We wouldn't need to be remediating. The only thing you can't do is what's been done before. Can you imagine having a better department head in your first high school job? Mathematics for liberal arts students 1 and 2 at Pan American. The least able of an open admissions university in terms of what testing would tell you. There I experienced how bad behaviorism could be. I had them all using the same notebook paper with the same width, rulers calibrated the same way, following the same set of instructions, with the goal of making at least the axiom of similar triangles plausible. And in a class of 27, I got 27 different pictures on the paper. College algebra, where I first realized that the curriculum is probably not the most important thing in learning. I used Nazario Villarreal's proof of the quadratic formula rather than the one I knew, and it was because I asked them to prove the theorem rather than showed them why it was true. Linear algebra and topology at Pan American. 2 of the first courses I ever got to give in a pure Moore method format, my choice, not the college's. And I was sure that my lemmas would be, take them exactly where they needed to go. And the students, of course, patiently proved my lemmas and then proved the main theorems with their own insights. Topology I gave in a summer course. And I recognized that at the end of the 6 weeks, had we been meeting 3 days a week rather than 5 days a week, we would have probably been at the very same place in terms of how much mathematics was accomplished. And I understood how much what I call fester time is important. Having time to think between classes instead of just class, 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 class being a big issue. Mathematics for liberal arts students. The wonderful summer of 1988 when I first used Moore method in the lowest numbered course in the curriculum at JMU, and the class taught me that it wasn't, the problem wasn't that they couldn't do it, the problem was that I had never asked them to do it before at that level. And then down at the bottom, the 5 courses I gave at Guilford this past year, in which I learned what it was like to be a first-year teacher again. As I took 27 years in which I had subconsciously built up what a class is like, because that was what a class was like at James Madison, and then I got the opportunity to see a completely different academic culture, taught on a completely different academic timetable, and scrambled like a son of a gun trying to get the job done. Because, as IBL teachers, we're listening rather than talking, we have assessment opportunities that other teachers don't have. I would suggest, rather than an assessment thing that you can compare to somebody else, that the real question in terms of testing is, at this stage of the course, what else do I need to know? Possible social challenges, peer expectations. Both those in your department and those outside of your department, if you're the only one using Moore method. Student expectations. Asking them to do something rather than showing them how to do something is going to be a shock. And then the level of preparation. That is the greatest variable that turns out, at least in my experience, is the least important. All right, what I'm going to do in the time I have remaining is to take you through 4 different categories of courses. That's where the 4 in my 5 count came from. I'm going to start with the math for liberal arts. I taught this at Pan American. I voted against adding it to the curriculum at James Madison, 1 or 2 in the department, and of course I was rewarded with teaching it because I had actually taught the course at Pan American. It's the lowest numbered course in the catalog. It's main population or math phobes, students looking for an easy 3 credit course to get their 6 hours for the Bachelor of Science. students who are well prepared for mathematics but were advised by an advisor just to get it out of the way rather than take the course they should. Real mixed bag. But the one thing you could be sure of at James Madison was that if they were admitted, I mean, even the football players, they had 2 years of high school and a year of geometry. Thing that if I could do, I could make the course succeed, was get them to readdress techniques for solving equations, or if I was given a more unit on geometry, the vocabulary of the basic structures of geometry. All right? So, what do I set as my platform for rigor? These are my expectations of the students, and they're right. I mean, I taught that course probably 30 times. I want to make the distinction between the words of logic and the words of mathematics and establish a core vocabulary for each. And then the classroom dynamic, in order to put them in a place where I can turn mathematics over to them, is insist that they use it. Yeah, that's a nice idea. Now, can you articulate that idea within something where we can use logic to validate whether we're right or not? That question I ask in 30 or 40 different ways, whatever is least likely to threaten or intimidate the student, being the version I choose on a given day. For the course structure, because of the nature of the audience, the first thing I want to do is take away deniability. They were admitted to the university. They've had Algebra 1, they've had Algebra 2, they've had geometry. So in the first course, we study Algebra 1 from high school as adults. With the core vocabulary that they've got, the field axioms are adequate for proving anything that's actually true. And that's the first unit. And it makes no difference how far they get, depending on what the more unit's going to be. If you're interested in reading more, I actually have just, I don't know whether it will get published or not, but prepared a very lengthy description of the day-by-day activities in this course in terms of how to turn math phobes into math doers. So after they have oriented themselves to the standards of rigor within their own comfort zones, I turn them loose on something they've never seen before, and that's the more unit. That was the epiphany of 1988 I talked about a while ago. I still can't believe it worked, but I've been doing it ever since. Keep in mind that in this course, it's not important that everybody succeed. The name of the course is the nature of mathematics. It's important that somebody succeed. And when somebody succeeds, then it's a peer, and they can be held accountable for being able to do what the other persons in the class did. And then finally, what happened in the first two units will tell you what to do in the third unit. I gave a talk 3 or 4 years ago at a sectional meeting at the MAA called Using Rubrics as a Blunt Instrument, or instead of and. Instead of setting up a grade scale and going from 1 to 100 and picking an arbitrary number, I want to know what else do I need to know. So I've got to reward what I've seen and then reinforce that reward with whatever assessment tool I build for the moment. So the thing that I typically can choose here, this is a core requirement. All they want is a credit. If they can articulate the first principles, and they can use the language of logic and distinguish between words of logic and words of mathematics, that's good enough for me. That's passing. If they'll do that plus one of my credit projects, that's enough for C. And if they do something, oh, that's enough for B. And if they do more than something, that's enough for A. And there's a good sliding scale that you can reward within, and you can make up artificial numbers for your grade book to make whoever's happy if they insist on add something up and divide by 4. Because you still get to give the test, you see. And I have yet to have a student complain because the grade was too high. This is the easiest course to deal with I've ever taught. The people that are in there because they want an easy grade don't make it. But the ill-prepared some of them do make it, they have no place to complain. And you don't have to worry about your colleagues. They're so happy you're teaching it instead of them, they ain't going to say a word. All right, for the service course things, I'm talking about calculus tomorrow in Angie's session, so that would have been my choice had she not given me that opportunity. But let's look at differential equations. They're going to have had 2 semesters of calculus to be in there, and most of them will have had 3 at James Madison. And the classical techniques of differential equations are directly linked to the calculus. So you've got a ready and built-in answer to the second question. So what do? The platform for rigor is just to be careful with the calculus. You see, because every time a calculus technique comes up, now this is probably one way that we as a group differ from a lot of our colleagues who are good lecturers. They want their students, because they've had it, to be able to knee-jerk a solution. I see them as an opportunity to do something again. So what are you going to do? Well, you're not going to just go through a behavioristic repeat of the technique. Here's an opportunity to say carefully what is meant in the calculus and build the foundations on which you want to do your differential equations. So every one of those is an opportunity to reteach within the indoctrination program. That's probably not a nice way to say it, is it? Within the enhanced opportunity to make arguments yourself. You see, because they get to use the language. And if you use the language, they'll begin to imitate you. I claim it's also a nice platform to teach an important but often not well taught, particularly if you use the books, point of logic. The difference between there is a solution and the difference, and if something is a solution, then this follows. That has poisoned Algebra 1 in the high schools for years, to think that solution simply says what it says rather than there being 2 big different logical issues. And in differential equations, you get that opportunity time and time again. So there's the new logic. The old logic is also going to be new to them if they've had a standard course in calculus that's technique-driven, but nevertheless, this is something that differential equations is made to order to try to make clear. The course structure I use build from what they know. So I make a unit out of classical techniques that are anchored into calculus. I've already said that I'm committed to proof regardless of what math course I teach. So I want to make a theory. The theory for the second order linear differential equation with continuous coefficient functions and affine function is a beautiful theory. And if you understand it, then the generalization to n takes care of itself. So I put a unit on the theory of the second order differential equation. And in this day and time, it's criminal not to teach a numerical unit in differential equations. So the third unit is numerical methods, and there's your 3-hour course. So there's a platform, anchor to what they know, build their ability to use language, build a theory that's got great applications, do numerical methods, and turn the theory into, can we actually say what kind of estimates being made rather than what is the algorithm for the numerical method. What's a C? Well, if they can do the problems and use my language, that's good enough for C. You'll notice this award, outlandish rewards for solving problems. That's a constant in my assessment. Somebody does something themselves, they need to be rewarded because that's what we're after. So that with one of those first 2, that's another way to make a C. That with both of those first 2, that's a good way to make a B. And if they knock your socks off, that's good enough for A. Keep in mind that in this day and time, understanding of what it's about, not implementation of the algorithms. Computers do that better than we do. There are challenges in this course. Don't do it this way unless you're willing to try to turn negative into positive. Because it's not going to be the way they would taught calculus unless you taught them calculus or one of your colleagues. I was in a department where I was the only more method person. So basically, but you are the one that can handle anything. So you turn everything on yourself. Instead of accusing them of being unclear, you act as if you're the one. Not you're wrong, but you're probably right. I just don't see why. And then model, you know what it is they're after because you know the language of the textbooks as well, but you can ask the right questions so that, oh, you mean by this, this. Oh, you mean, oh. And then you can say it using the language you're trying to get them to use. And son of a gun, they're getting the equipment to where they can put themselves in a scenario where proof is adjudicated by logic as opposed to by approval from the back of the book or approval of the expert, which is what I think we're after. When you say take the integral of both sides. You see, that's a place where a metaphor, you know exactly what they mean, but they don't know exactly what they mean. But if they'll say it, they get in the habit of mind that's special to our discipline. So you can both turn it on yourself and at the same time put them in opportunities where the translation within the fixed vocabulary of the subject does the job without having to include the metaphor. Metaphors are great for having ideas. Mathematics is great for validating ideas. And I may sound like a broken record, but praise something that comes close to what you want. Oh, that sounds good. Say that again. All right. Now, there's been a lot of interest in this course at the workshops over the past few years. I was lucky enough at James Madison to be a part of both several curriculum developments in this and to get to teach all three of the courses that James Madison has in his curriculum after we went to three. But I'm talking about the first one here. That's about the algorithms of arithmetic and counting and place value enumeration. Here's a place where what I expect from them, if they got out of grade school, they can probably do. I just want them to know the algorithms for place value enumeration, for plus, times, division, and subtraction on base 10 numerals. And then if I can cast place value enumeration within the language of the theory of sets, and I can cast language itself into grammar and semantics to take the place of logic and mathematics, then I've got a chance of having them succeed. So I give them the language of logic, the theory of sets. I teach a unit on language where the big goal is for them to take sentences they find in the wild and parse them and separate them into grammar and semantics. And then it's a very, very small step. Now understand that that's largely been weeded out of the language arts curriculum, unfortunately, but nevertheless it's something that they can identify with. Can you actually say what this sentence means from a structural point of view? So that to understand it, all you have to do is deal with the semantics. And that makes the case for axiomatic systems. And then I teach them to count from the set theoretic point of view by simply making a matching principle, not articulated within the language of sets, but applied to sets. So we have matching principles that supports counting, and then the structure of place value enumeration. Once we start making counts and making numerals for counts, every day the class picks their organizer for the day, and they can pick anything but this many. And then we repeat the place value enumeration rules, make the enumeration system with their choice of symbols, and start doing the arithmetic. So the 3 units here are get good at language, make the enumeration system, and then go in and validate on the basis of the way that plus and minus are defined. They are my 2 primitives for counting. And then to actually verify that the algorithms give correct answers. and then to go back and try to find counts that say why the algorithms work. That's a beautiful unit and fun to teach, by the way. So what you've done essentially is gotten to the college level by using language and rigor well, but you're working with the ideas the way the children they teach will be working with them. Because the first thing basic to arithmetic is learning to count. And then the arithmetic follows from counting. All right? Well, what's the other thing? Well, where the student's heading. Well, since you've already done language and logic, you can actually articulate the field actions. So you articulate the field actions, you declare place value numerals for this as the organizer to be numbers, and then you go after the algorithms from the algebra version by doing algebra on arithmetic objects. The field actions are adequate to give explanations, and they always get plus, they always get, well, with some prodding they get minus, they find some algebra theorems. You can't be sure they're going to get division though. That's the one that most often doesn't happen. But about 40% of the classes I've taught have gotten the division algorithm that explained algebraically as well. Assessment. This is a tough call. This is one class where your F's are more important than your A's. Whenever I advised a new faculty member, I pointed out to them, this person may teach your child or my grandchild. Keep that in mind when you make your grades. It's very, very important you say no to the right people. On the other hand, the idea is not to teach them everything they need to teach. By God, if they got through grade school without learning that, the idea is to teach them to teach themselves what they don't know. And you want that instead of being operant, you want it to be purposeful. And that's the role of rigor. It's an interesting social audience. At JMU, this is a hard-working bunch. As long as hard work means give them mindless drill and they'll tell them how to do them all, because they'll do that. On the other hand, that's not what we want. We want them thinking about things, but we still want them to use that time. So the idea is to find something that tickles their fancy well enough to get them to commit the time in something besides mindless drill. But that's not easy. At least, for me that has not been easy. I would have loved to have found what switch would to flip on that. I have had the thing that this is a course that I've had some of my greatest frustration in, because I have had classes that just achieved. I'd be willing to give them intro to proof credit because of what they've done. And then I read this student evaluations of the course, and they have made no connection with what they might be able to do with a child. Stan probably figured out a way to make that happen, but I've been near suicidal after some of these courses because they've done such beautiful work, and I know what they're capable of as teachers now, and they don't see the connection. Okay, now, place where Moore Method actually has at least some tacit acceptance in the larger university world, in the major. By the way, an ongoing discussion I've had with colleagues within the department everywhere I've ever been. Rigor's fine for the majors. I think it's backwards. The majors, if they don't get hold of rigor, are not going to get degrees in mathematics. You get somebody in calculus, that might be your only crack. You get somebody in math for elementary school teachers, that might be your only crack. It's much, much more important that rigor play a central role in a one-shot deal than it is in a place where rigor is going to take over. So, at James Madison, the first thing that would be a proof course, they're going to have at least the beginnings of the calculus sequence. And my response to foundations is start from scratch. It's all about proving theorems. So distinguish between the words of logic and the words of mathematics. Does this look an awful lot like my math for liberal arts? Yes, the very same philosophy. Except this time you get a bigger fish to fry. Instead of somebody succeeding, we want everybody to succeed. I'm sorry, we want to insist that there be success. Establish the core vocabulary. Insist that the students use both as they work on the problems. There isn't but one way to do it, in my mind. If you're going to teach somebody to prove theorems, you don't show them. You put them in a situation where they can prove theorems, and you turn them loose. And as soon as somebody gets one, somebody else will get one. Mathematicians' education doesn't go like this. It goes like this. And when this is going to happen, you never know. But there's no going back when it happens. On the other hand, and that's a good lecture. Now, if it's a first proofs course, I do, at least at the beginning, do some work on language. Very much in the spirit of what I do with the prospective elementary school teachers. I'll give them the first few definitions or the first few problems and have them parse them so that I can be sure that they recognize the distinction between which words are logic and which words are mathematics. But if they've had the Intro to Proof course, I just deal with the logic as it comes. If you want to know about assessment, read my part of the essay on grading in the book. Possible social challenges, I'm not the right person to talk to. You know, the cultured person you see, I'm actually hopelessly naive. I don't know but one way to do things. Let's go in there and see what happens and then try to make it work. But Stan knows everything. You talk about somebody with his pulse on what students are like. So he's the best authority I know. I have done more marketing since I met Stan than I did in the first 30 years of my career. Well, in the first 6 months after I met Stan, I did more marketing. See, Mike's out there. 7 or 8 years ago, Mike, at this conference, I remember you saying, it was the day that you won some big teaching award here. And you said, a lot could go bad the rest of this day, and I'm going to still feel pretty darn good. You remember that? All right. Well, I got an email just last week. My afterglow is going to be more than just the last of the day. This student I had as a freshman advisee. He was an ordinary major, did really well in the statistics, had a fellowship in statistics, took my analysis course as a senior. First semester, he was wrong as often as he was right. Second semester, by the end of it, he was a tiger. And because he felt obligations, he didn't go looking for math support. He did what he had signed on to, but they let him take math courses at Oregon State. I get this letter last week. Dear Dr. Parker, checking in. Hope everything's going well. Look about halfway down there. Now, he said some nice things about me, but look at this. Every day, I try to live up to the expectations that I set for myself after taking your classes. This is what it's all about. Thank you so much.